This lesson is on English and metric conversions. First, we'll start out with a quick review of the metric system. In the metric system, units are all factors of 10 of each other, which makes it very easy to convert from one to the other. There are base units that have prefixes for them, and all scientists use the metric system so that they're all speaking the same language, and because it is more convenient to use. Base units, you should know the most common three: the meter, measuring length, the liter, measuring volume, and the gram, measuring mass. There are prefixes in your book on page 35. The 6 most common you should know are kilo, hecto, deca, in order from largest to smallest. So then at this point would be the base unit, like a meter, liter, or gram. Then getting smaller than the base unit would be deci, centi, and milli. Metric units can be converted by simply moving a decimal. If you can remember this order for these 6 most common ones, it is fairly simple. For example, if you had the number 17, let's say it was liters, and we wanted to find out how many milliliters that was. You would take the decimal, where it is right now, which is after the number if it's not written, and you're going to move it, and we're going to go to the right. The reason I know we're going to the right is a milliliter is smaller, so your number should be getting larger. If you look back up here at our symbols for all of our prefixes, we're just going to count how many spots over. So the liter is at the base unit, so we're going to go 1 spot for deci, 2 for centi, 3 for milli. So we do exactly the same with our number, 1, 2, 3. Each of those divots would be a 0, so this is 17,000 milliliters. All right, moving on. Factor label conversions. These are conversions when it is not as simple as moving a decimal. These would be from one English unit to another English unit, such as inches to yards, or a metric unit to an English unit, like meters to yards. The basic setup will have 2 conversion factors, 2 things that you are multiplying. It will look like this. Okay. And the top left will be what you are given. Sometimes if it has only 1 unit, it'll just be on the top over 1. If it has 2 units, which we'll get to, the second unit would be on the bottom, like a rate, like meters per second. The second side is going to be your conversion factor. These you will find on a sheet that you will be given or in your textbook. For instance, the unit on the bottom right would have the same unit as your given information. This is so that you may cancel it out. For example, like in math, if you had 5x divided by x, you would simplify by dividing out x. It works the same in this kind of problem with the units. On top then would be the unit you want to change to. And this is a very simple one-step problem setup. So let's do a problem like this. All right, for example, if I had 4.5 inches and I wanted to know how many centimeters that was, I would set it up like this. Start with my given, 4.5 inches. I'm going to write that over 1. And then I need to know my conversion factor. I'm going to start with just the units. We'll do numbers second. Inches on top, so I want to have inches on the bottom so that inches will cancel. We want them to go away. And then I want to convert to centimeters, so centimeters would be on top. The numbers are going to be found on that sheet I referred to earlier. For these two, it is 1 inch equals 2.54 centimeters. Something to note. In this equality on the right, the top and bottom always equal each other. So now at this point, I can cancel out or divide out inches. So my unit is centimeters for my answer. And now I would go to my calculator. I would take 4.5 times 2.54. Dividing by 1 doesn't change anything. So my calculator tells me that the answer is 11.43. That is not your final answer, though. You have to look at significant digits. The first number you're given has 2. Typically, your answer is going to have the same number of sig digs as that first given number, but you have to look at your equalities as well. 2.54 has 3, but this number is exact. Most are not exact, and you will see this on your sheet. If it is exact, you're going to look at just your given, the one that was measured. So my answer can only have 2 because that's what my given has. We're going to ignore exact numbers. So this would actually be 11 centimeters. Now, moving on, you're going to have problems that are not as straightforward as this. You're going to have multi-step problems. This might be something like if you had 1.2 miles and you wanted to know how many inches that would be. Okay. On your sheet, it does not say how many inches are in a mile, but it does say how many feet are in a mile, and then you should know how many inches are in a foot. So for this problem, we are going to go convert miles to feet, because our sheet tells us we can do that, and then feet to inches. So we'll start out by writing our given, and we'll do that first conversion to feet. Miles on the bottom, so it'll divide out. Feet on top. The sheet says that 1 mile equals 5,280 feet. Here's another exact number, like the centimeters and inches. I can divide out miles. And now I can keep going. This is much shorter and simpler than writing equals, finding your answer, and then doing the next step. Do it all in one problem. Taking feet, I want to get rid of that, so I put that on the bottom and the next side. And I want to go to inches on top. In 1 foot, there are 12 inches. Remember, the top and bottom of these two should equal each other. And I can divide out feet. So now in my calculator, I would do 1.2 times 5,280 times 12. My calculator tells me the answer is 76,032. But I have to look at sig digs. 5,280 and 12 are both exact, so I'm going to look at my given, which has 2. So my answer would actually be 7,600, or a better answer would actually be 7.6 times 10 to the 4th inches. Some problems will have 2 units, like I said earlier, meters per second, like a rate. So if I had 65 miles per hour, okay, I may want to know how many kilometers per minute that was. So setting it up slightly differently because you have 2 units. So the miles is on top per hour, so the hour would be on the bottom instead of the 1. 65 miles per hour. If you want to write the 1, you can. We're going to deal with 1 unit at a time. I'm going to start with miles and ignore the hours for just a minute. So I want to cancel miles, so bottom. I want to convert to kilometers, so on the top. On my paper, it says that 1 mile equals 1.6093. This is not exact, so I am going to look at this when I take into account sig digs. Miles divides out, so I'm going to get rid of it. If I found my answer at this point, my answer would have units of kilometers per hour. but I want kilometers per minute, so I'm going to keep going. Getting rid of hours this time. I want it on the top. It needs to be top and bottom if you're going to divide it out. So on the bottom would be minutes. In 1 hour, there are 60 minutes, which we know to be exact, and I'm going to divide out hours. Looking at your units, kilometers on top, per minute on the bottom. Now I know I'm ready to go to my calculator and solve. In your calculator, you would take 65, you would multiply by times 1.6093, and then you would divide by 60. Go through each section at a time. Think of it like in groups like this. Divide by any numbers on the top, multiply by any numbers on the top, divide by any numbers on the bottom. You can ignore ones. Multiplying and dividing by 1 does not affect your answer. For this one, the answer is, on my calculator, 1.73 repeating. Looking at my numbers, I ignore minutes, it's exact. I look at my other two. 65 is the smaller number of sig digs. This one has 5 sig digs. This one has 2. My answer can only have 2 then. You can only be as accurate as your least accurate measurement. So this would be 1.7 kilometers per minute. And one last problem will be an area conversion. So for example, if we had 27 meters squared, we may want to know how many yards squared that is. Okay, so we set it up the same. 27 meters squared. I want to cancel out meters squared, so the bottom, I want to convert to yards squared, so on top. On the paper, it says that 1 meter equals 1.0936 yards. Those are not the numbers, however, that I'm going to put into my problem, because I want meters squared and yards squared. You have to think of it as, if you have 1 meter by 1 meter, that's a meter squared. It'd be the same thing for a yard, but for 1 meter it would be 1.0936 yards by 1.0936 yards. To find the area for that second box, you would need to multiply them or square it, because it's the same. So 1.0936 squared is 1.1960. I kept the same number of significant digits. And that equals 1 meter squared. So meters squared will divide out. I have to look at both numbers for significant digits. This is 2. This is 5, so my answer will have 2. My calculator tells me the answer is 32.29, and so on. I can only say 32 yards squared.